Hello, in this video, we're going to talk about big O in the average slash worst case. So let's consider our favorite algorithm again, the largest uh, function, that if we measure its performance multiple times, even each time with a different list, but all these different lists, they have the same size. So over the multiple runs, do these multiple runs take like the same amount of time? So think about this for a moment. The answer is yes, they are. Most of them are going to uh, run in about the same amount of time. I mean, there are going to be small variations, but by and large, they're going to be very similar, right? And the reason for that is the function always have to look through the entire list to find the one that is the largest. So as long as the size of the input is the same, then and obviously if you run it on the same machine and all that, it's all the different runs are going to take the same amount of time. Okay, what about this one? This function is a linear search function that, given a list, given a key, it's going to look for the key in the list, and as soon as it finds that key, then it returns the index of where the item exists in the list. Okay, so what about this function? If if over multiple runs, and if it's given a different list and a different key, but if all the lists have the same size, does this function always run in the same amount of time? So when you think about it, the answer is really no. They don't always take the same amount of time, even for lists of the same size. That is because it depends on where the key is in the list, right? So if the key is the very first element of the list, then as soon as found, then we return. So that is going to be very, very quick, right? So that is actually the best case scenario. Now, or the key can be the last item in the list, or that it doesn't exist, in which case we'll have to search through the entire list before we realize that. So that is, looking through the entire list is kind of the worst case scenario. And that will be O of n, right, linear. Now, more often, it's probably that key is somewhere in the middle of the list. So we can kind of say, on average, then, if you do enough statistical analysis, you kind of see on average, we're probably going to search through half of the list to find the key. So the average case scenario would be something on the order of n over 2. Okay, but remember, big O really doesn't care about the scaling factor in front of n, the 1.5 in front of n. So in terms of big O, it's really just O of n. And it's the same as worst case scenario, even though in practice, the average is usually better than the worst case. Okay, so I would just want to point that out that, when we're talking about performance of an algorithm, we have to be very mindful of the average case and the worst case. And often they are the same, but sometimes they can be different. So the average case is how the algorithm performs on average, right? By definition. And so it's a very useful matrix, but it's also kind of hard to gauge just because, like I said, it could involve a lot of kind of statistics. And if you've done statistics before, it's a fairly complex branch of science or math. Also, we have to know about the worst case, and the worst case is usually actually easier to see because there's really just most of the time one way to get to the worst case, right? And so that is probably the most important metric because it does happen, okay? So Murphy's law, right? If it can happen, it will happen. So it does happen, and when it does happen, then it can cause serious problem, right? If the time, if the big O of it is some bad function, right? So we are most of the time we are concerned with the worst case, and you can also then deduce from there is that when there are optimizations such as, well, this is not even an optimization, but we can think of it as an optimization that if we find the key, we return, right? We usually don't consider the optimizations because optimizations don't always happen. So we have to consider the worst case when optimizations do not happen. Okay. And what about the best case? Well, best case is well, they usually don't happen, and even if they do, they don't cause any problems. So we're not concerned about best cases. So again, when talking about algorithm performance, we generally are just concerned with the average case, but more importantly, the worst case.